My name's Grant Paling. I'm a product manager for Managed Detection and Response Services at Orange Cyberdefense. And my talk today is entitled Staying Ahead of Machines, Why You Haven't Been Replaced by a Robot Yet. So one of the main questions to start off that I get asked a lot and that kind of starts off this presentation is, what are machines capable of? AI, machine learning are buzzwords that are just floating around the cybersecurity industry at the moment, just everywhere. Everybody's got the latest and greatest AI. And you know, we've had a talk from Steve at Fortinet this morning about how they're using it. What I kind of want to approach it from is, you know, taking a step back and looking at what actually is AI, what is it capable of, and you know, it's a definition that not many people like. They think that it's kind of misused. It is actually the right definition, artificial intelligence, in the way that it's used in the industry, but I think what is misused is the way it's used in marketing and the way that it's perceived. I think our concept of AI is often what you see up here, the Hollywood version. And I think, you know, generally this is a news article that came out in the BBC last year from the Office of National Statistics around 1.5 million jobs at threat from being replaced and automated. Looking at that article, it took through some of the most at-risk jobs and some of the least at-risk jobs. So things like waiters, shelf fillers, elementary sales occupations. For those of you that get bothered by cold callers often, as we often do in this industry, you know, soon you'll be saying, is that a script they're reading off, or have they just been programmed that way? You know, and then you've got some of those least at-risk jobs, things like dental practitioners, you know, medical practitioners, doctors. We're not really that comfortable with being kind of prodded around by a human, let alone a robot. So these are some of the kind of, you know, the jobs that have been kind of pointed out. But what about the cybersecurity industry? And we've got an entirely different problem. We would love to automate more of our jobs, I think. We have a well-documented skill shortage globally. And you know, this could be any quote from any kind of study. You know, every study on this topic shows a massive skills shortage. In this instance, 63% of respondents report their organizations are understaffed for cybersecurity. I think maybe the other third just don't know it yet. And within this particular study, there was, you know, some of the things we point out, which jobs are we actually understaffed for? And when you look at these topics, you have things like security awareness, where you can't automate that with a robot. Things like risk assessment, analysis, and management. Again, some of these are quite complex topics, and they would require maybe the Hollywood version of AI to completely automate that kind of function. So one of the things, you know, I want to talk about is what we can do. And first we'll start with why we can't do it. And the thing is, AI is just not intelligent enough yet. There are people studying this. So this chap is Sir Roger Penrose. He's most famous for working with Stephen Hawking on black hole theories. In his spare time, he's looking at AI. He's got an institute set up. He's trying to start to map the human brain and map some of these functions that are just kind of a mystery to us. And one of the things they were trying to do was they posted an advert in a number of journals looking for people who could solve this chess problem. And what's unique about this chess problem is that a human chess player will see that there is a way to draw or even win if you are the white, who is in severe trouble in the situation, whereas a computer sees it as a loss immediately and will give up the game. Now, why is that? That's because there are so many different things and factors to consider in this particular position that even the biggest supercomputer in the world cannot compute the same outcome as just what they deem as an average chess player. So there's something in the human mind that allows us to kind of reach outside of those boundaries that are still in place for computers. So going back to our perception of AI and starting with that problem again, there's a wonderful blog called The 7 Deadly Sins of Predicting the Future of AI by a guy called Rodney Brooks. So I would encourage you to read it if you just want to understand a bit more about artificial intelligence generally. And he talks about, first of all, 4 general topics, and they're kind of in ascending order, things that we misunderstand. The first of all, what most of us think of as AI is what is actually artificial general intelligence. That's the technical term for a machine that would completely replicate the human mind. Okay? Artificial intelligence actually is just replicating functions of the human brain, or functions that we perform. The second is this kind of notion of the singularity, and this is why some scientists are concerned. There's quite a lot of debate about this in the scientific community, right? The singularity is, this idea that all machines kind of share this hive mind, and that for some reason, because they're all connected, they will all start to rise up against us, or they will certainly start to share some thinking. And kind of related to that is this idea of misaligned values. So for example, if you have one machine that is dedicated to making paper clips and manages to convince all of the other machines to make paper clips instead of manufacturing cars, processing food, all of these things that we need to survive, that we'll just have a load of paper clips and we won't be able to survive, right? There are scientists that think this is actually a problem. And then this one, number 4, the Hollywood version, really evil, horrible, nasty, human-destroying artificial intelligence machines. So in reality, we're not really close to any of those outcomes, and they are common misconceptions. But there are some deadly sins that we make. I'm not going to go through all of them. I would suggest read the blog. I'm going to go through the first 3. The first one is we overestimate the impact of AI in the short term, and we underestimate it in the long term. Okay? And I think that's kind of true in the cybersecurity industry. Almost when we started introducing these terms, AI and machine learning, we were like, okay, this is going to solve the problem. We don't need to outsource. Just when maybe we were about to outsource something, now we've got this machine that's going to come and do it for us. That's just not true. It's just not how it works. The second one is the way, as I said, in which it's portrayed in the cybersecurity industry. This idea that, this is an idea from the science fiction writer Arthur C. Clarke, that if something is that far beyond our comprehension that we can't understand it, it just seems like magic. So again, I would encourage everyone to educate yourselves on it. For me, it started with actually a podcast that wasn't even about cybersecurity. It was with Sir Roger Penrose. Just understanding, some of the general concepts and then getting into the cybersecurity part. And the third one is performance versus competence. So just because a machine is good at one thing doesn't mean it's going to be good at others. So actually, when you're looking at cybersecurity tools and technologies, that ability to do one thing well, the machine learning model that they're using might not necessarily be appropriate for other things that they want to introduce. If we look at, for example, things like command and control traffic and identifying that versus privileged access management, in good technologies, those things use different learning models because they're looking at different types of things. One is looking, at attacker behavior. One is looking at something that might actually be conducted by end users that are legitimate. So these are some of the things that you've got to consider. And there's no doubt about it, machine learning is powerful. We're at an age where it is, it's an essential thing to be able to use in cybersecurity. This ability to extract features, the example here is with sound waves, being interpreted, the ability for Google, for example, to translate languages in real time. It's truly amazing. But it's also vulnerable. I think a lot of the conception also is that maybe AI and machine learning is kind of foolproof, that it's not as easily fooled as perhaps traditional antivirus, for example. And that's kind of true, but it doesn't mean it's invulnerable. And often, there's this conception that, well, you'd have to have access to the underlying machine learning model, to the code, to be able to understand this. And actually, you wouldn't necessarily need that. And one of the reasons for that is APIs. We all love APIs, right? In the industry now, everything has to interoperate or to be capable of interoperating. And APIs actually give away the data that we would need. All we need to do is understand, if we were going to exploit this, to choose our own architectural model. It doesn't even have to be the same machine learning model that the technology is using. We just need knowledge of the input and output. And if we're an attacker, we don't even need a high number of queries. We can use a low number of queries. It's harder to detect. If we're doing it in our own test environment away from a customer as well, all we need is the ability to learn when we input something, what's the decision? And if we do that enough times, we then learn the decision boundaries. And let's say if it's working on maybe a risk score-based system, if we can just move it down from 90 to 60 in that gray area, then maybe we can get past the system, or at least force them to do more work, which then accentuates this kind of skills problem. And we can use iterative changes to identify small perturbations, differences in what we're doing in terms of the data that we are feeding the system, to cause, eventually we're going to cause that desired misclassification, right? It's going to happen. It's just the nature of this type of detection capability. And there's documented methodologies around this already. Papinot et al. Is probably the most comprehensive study in this area. And again, they looked at this theory of, they were able to break, this wasn't necessarily security focused, this was just breaking AI models, but the same concepts exist, right? They were able to substitute these data sets, feed in those, label them, and train their model based on the output of APIs from people like AWS, Google, and able to fool those data sets eventually with an accuracy of around 85 to 95%. Who's to say that you can't do that for security? Now, there's two reasons we're not really seeing this massively out in the wild in security. One is that a lot of people are still using signature-based technology and those kind of methods. And the second one is, why spend time trying to break it when you can use it yourself? And one of the things that we've been looking at in our research team is, what are the potential offensive use cases? Because surely they're going to be much easier than defensive use cases. With defensive use cases, we're facing attackers that continuously adapt. So we continuously have to update the machine learning models and the AI systems that we're using. For an offensive use, you're looking at a set of victims that don't tend to change their behavior. All we have to do is, use the same kind of, and we're trying to exploit the same people, the people that are there to be exploited, that are naive, that very innocently are just doing the things that we expect them to do. So there are some concepts that we're starting to see, that potentially could change the way in which we face attacks. Things like deep phishing techniques, the ability to exploit images and again learn those decision boundaries so that we can get past systems. Also, kind of, you have a lot of feedback now within systems to be able to mark something as a phishing email that feeds a lot of the technology's ability, and that's their kind of living and breathing data set. Well, who's to say that we can't, as attackers, potentially get access to those and feed it bad information? So mark something as a phishing scam when it's not, or the other way around. But a lot of this is quite theoretical and proof of concept. So what we wanted to do was actually come up with some real examples. So we set our research team on the case with this. And really we were looking at exploiting features. And features really, are often bugs dressed up really. What we were looking at is, first of all, let's start with the obvious. If we're looking for features that could be exploited, we tend to start with Microsoft. We tend to start with Microsoft Office. There's a history there. From PDFs to macros to Excel, throughout history, there's a history of exploitation there. So there's an interesting feature that Microsoft introduced called DDE, and this is a machine learning feature that basically allows you to do what's called topic modeling. What could possibly go wrong by introducing this feature? It's there to make our lives easier, right? Yes, it's there to make our lives easier, even if we're an attacker. And topic modeling is quite a simple concept on the face of it. It's there to help us organize, visualize, summarize, search, predict, understand. It's there as almost a librarian within our networks to understand, the trends that we see, how to organize data, to make things easier, be like a personal assistant to us. So it allows us to discover these different themes in text, to annotate documents and organize them. It basically learns the distributions within a document based on these topics, and will help us to organize them, assigning every word in a document a topic, so we can then easily search this data. So what we wanted to do was manipulate that in a way that basically turns these librarians a little bit evil. What if we could use it offensively? And effectively, typically we see the stages of an attack. There'll be a reconnaissance, an attempt to infiltrate, let's say, an endpoint or an account or a number of endpoints and accounts, and then start to look around the network, see what we can find. What if we could automate that process? So that's the first kind of concept we were looking at. But the other one was to also industrialize typo squatting, which is an attack that doesn't even need to infiltrate the network. So these are the two things that I'm going to talk about. The first one then is that accurate data map of a network. We tested it on our CTO because he's crazy and he likes to have these things tested on himself. And in 2 minutes, we'd identified 800 files. We used a watering hole attack, again, all simulated, but all very, very realistic. And it was pretty scary what we could find on his machine. We could easily identify valuable information. And we were using Cobalt Strike, again, a common tool used by attackers, to basically create this scenario. So we wanted to create our fake command and control center, direct him there. He was playing the role of unwitting user in this particular exercise. Get the documents with those principal topics that we were interested in, and use topic modeling to identify those documents. And then exfiltrate those documents. So the other part of this exercise was, it's going to be pretty obvious if we own this machine when we start exfiltrating every single document on there. What we want to do to maybe be less noisy in this type of attack is to actually look at whether we could reduce the amount of documents we needed to exfiltrate, again, using this topic modeling technique. So we've got this user to go to that fake watering hole site, the one you saw with the zebras. And again, once they've gone to the site, they've clicked the little run buttons that they do. We've managed to get to this point, and what you can see here is our attacker configuring different parts of the attack within Cobalt Strike. The important bit is at the bottom here, those principal topics that we are looking for. So in this simulation, we were looking for network configuration, infrastructure, passwords, the type of thing that's interesting to an attacker. So rather than having to look through all of these files that we've now got access to on this end user's machine, quickly point us to the right place and be able to then extract those files. We have a longer version of this simulation. It's something that we can organize as a follow-up if people are interested to see the whole attack demonstrated. We don't have time here. But just to give you some insight, what we were able to do then is find all of these files very quickly, very accurately, and demonstrate that we could get access to some pretty interesting data. Network diagrams, confidential information, and again, all very efficiently done, all exfiltrated, and then clean up, so remove all those topic modeling tools that we downloaded to the endpoint. The second one is when you really want a lot of email to just come to you, but you can't be bothered to check it all. This is kind of what we did. First of all, we select an industry. In this is again a realistic type of attack. This is based on the real estate industry. We decided we wanted to capture some of their email. In fact, a lot of their email. So again, what we're trying to do here is capture some emails that may be sent to us by mistake, and then intercept those, and then reply, and lull the user into giving us some money, saying, oh, the details have changed, you need to actually send the money for your mortgage here, and things like that. We picked, I think it was the top 6 real estate agencies in the UK, so we could enumerate those players. And it's really easy to do typo squatting. Again, it's all automated. You have domain generation algorithms that will look at all these different kind of combinations that will just be a slight variation on the real domain to be able to generate these lists for us. We go and see if they're registered. If they're not, great, we register the domain, we set it up, set up a mail server, maybe set up some addresses that are there. And again, using something like LinkedIn, it wouldn't be that difficult to find out who's the CEO, set up a fake email address, and see what they're getting. How many people have fat-fingered a domain? It's one of these things that's just really easy to do when you're typing an email, especially for the first time, especially if it's not somebody you communicate with every day. So that's what we did. And we had success. I think we got over 500,000 emails by accident, which we then wanted to look through. And it would be things like this one where, you have contract packs that are going to be received. We were intercepting that. Can you let me know whether the client has a related purchase, and if so, what stage that has reached? We can feed in whatever information we like from here and start the scam going, because again, we've emailed this person already. If they reply with a very realistic looking email, then we've immediately got that trust. And the great thing is autofill, when we reply, we'll just send it back to them, if we're sending a new email, if we're not just replying. So how to scale this as an attacker? Well, it requires manual investigation of potentially hundreds of mailboxes and thousands of emails. As I said, we receive quite a lot. But it's the same principle. We could use topic modeling to say, well, we're interested in these topics. We're interested in the words like transaction. We're interested in words like bank details. We're interested in words like conveyancing, final kind of steps in the chain. So it's not that difficult using the same method for us to go and find this kind of thing. Again, find financial information, patent information. This stuff doesn't just apply to this particular industry. It could be adapted for any industry. All we need to know is the important type of information that's likely to be being sent over email. So again, there's another demonstration. I don't have much time, but again, this is something we can demonstrate. But with this one, the interesting thing is we didn't have to infiltrate any networks. We just had to set up some domains and wait, and we'd get that information. And again, we can configure this how we like. So we can look at, again, the types of information that we want to look for and start to see that. I might let it run just for a little bit so that we can start to see some of the results that came back. That's going to take too long. Live demos. Okay, so where does AI fit in cybersecurity from a defensive point of view? We've talked about how it can be broken. We've talked about how it can be exploited. What about the defenders then? We have obviously a lot of experience on this side. And it's most useful if we look at the typical stages of incident response and the typical life cycle. This is based on standard practices from the Association of Chief of Police Officers. The common phases of incident response. Identification is probably the area in which machine learning and AI are most useful to us. It allows us to, start to identify, especially common attacks with much more visibility, much more breadth, but it also creates a problem in that things aren't black and white anymore. There's often this gray area where we have to observe over time maybe an attack unfolding. And when I say over time, that might be 1 or 2 minutes, but rather than interjecting, let's say, on a single alert, looking at a number of behaviors that happen over time and having somebody analyze that. That's kind of the way that it works. It's the only way it really works. Pavel, who's on after me from Cyber Reason, is going to demonstrate detecting an advanced attack using the technology. But without somebody to then interpret that data and take action on it. That's where containment is possible, and it's possible to get you up to that point of decision, but we're not there in terms of relying on robots to make that decision yet. We're not at that point of saying, yeah, we'll quarantine everything, clean it all up, let the machines run wild on our network. It's not a good idea. There are technology vendors out there kind of peddling this idea of automated remediation. That's just quarantine. It's like putting quarantine spam emails in your mailbox. It's been around for a long time. It doesn't solve the problem. Eradication, is a human effort. We can use the data we get from that identification stage, and this is a cycle within incident response. You go back, you try to identify as the investigation unfolds. You can use that AI and machine learning technology to go back and find out how far the incident has spread, but you do need the human effort alongside it. And then, of course, lessons learned and recovery. These are human traits. These are things that we have to build back in. Machines won't do that for us. We have to take what we've learned from incident response into our processes, into our procedures, into our security awareness programs, and make sure that these things can't happen again. We have to improve our networks. We have to take whatever advice we get. And again, this is just not anywhere near being automated. And then we have preparation. It all goes back into that kind of human input. What do we do next? How do we recover from an attack? And then how do we reset and go again? So kind of recapping, going back to the start, the shortage of skills is growing. Resourcing is a problem, and it's not one that on its own is solved by artificial intelligence and machine learning. There's more online exposure, as I showed, in the demonstration, with that domain squatting exercise. More and more of our infrastructure is now outside of our control. So we need a way to start to monitor that. And again, AI and machine learning allows us to do that, but then it creates even more for us to know about, even more noise to sift through. The proliferation of cloud services. again, more places for our end users, whether they're application developers or whether they are just end users who know a little bit and are a bit tech savvy, opening up these new environments that are, again, outside of our control. And regulation. On top of all this, expansion is the pressure to respond. So, with all these components, they're things that we use in our everyday activities. So, as I said, I'm product manager for managed detection and response. So, our challenge is how do we use these types of detection components? How do we use them effectively? And again, it all comes back to what we call our CyberSOCs, our network of advanced security operations centers, where we have people looking at this data, where we can take threat intelligence from it. And again, a lot of that is human-driven. These things change very quickly. You can't rely on a machine necessarily to monitor things like threat intelligence that we've extracted from this kind of data. And also flipping it to the modern enterprise. You have what I call customer controlled assets and data. Not necessarily the perimeter anymore, because the perimeter is kind of disappearing, but at least things that are in your control, in your visibility, and that you know about. And as I mentioned, this new frontier of, well, what's outside of that? What data exists outside of that? What systems that we own, whether we know it or not, exists across open, deep, and dark web, and having some kind of digital risk management platform. And then being able to tie these things together. Understanding, well, we have a domain squatting, we've identified a potential domain squat. And if you're only looking at the outside bit, which is kind of where this capability is being, it's very isolated in the security industry. Wouldn't it be better if we could see, a potential domain squatting incident and whether anyone was actually connecting to it if we had the visibility on the inside as well? And that's the concept which we're looking at. So positioning all of these things together, as I said, all machine learning and AI technologies are not equal. What kind of value do they provide? MITRE ATT&CK framework is something that is gaining a lot of exposure. Quite rightly, it's a very good initiative. One of the things that we've done is put together a detection framework that allows customers to map, first of all, where do they actually want to be? Where can they be? What are the typical types of adversaries that they will be facing? Is it nation state sponsored, or more likely is it maybe some of these opportunistic attackers that use some of the techniques which we showed in our research and which I talked about earlier on. Once we've mapped that, where do we have detection coverage? What kind of detection techniques, including machine learning and AI, are going to be useful to us in what areas, and at what stages of the cyber kill chain are they able to detect attacks? Because again, as I said, not all machine learning is going to protect you everywhere. And then we can start to model changes as well. So we're not just going to give you a data set sheet that says we can protect you 100% in every area. What we're talking to customers about now is mapping to that. Where are we now? And if we modeled in these changes, if we want to make investments of security, where's that going to take us? Where can we actually improve our visibility and that ability to detect threats? In summary, take some time to understand artificial intelligence and machine learning. It's not magic. It is fairly new still in cybersecurity. I would recommend reading some of the resources that I talked about. Understand the tasks that AI is conducting. You can't automate entire jobs, but you can automate some functions. This is an important one. Question vendors on the depth and variety of models they're using. If they're using one machine learning model for everything, it's likely that that's quite a flawed approach. And how are they protecting themselves from these kind of black box and poisoning attacks? Ensure you have the capacity to use any technology you invest in this area, or if not, use a credible managed services provider. Shameless plug, sorry. And understand where the criminals are already using it. So again, understand your ability to detect threats and also where it's being used, and also to quantify that risk. And finally, like anything, AI and ML doesn't just work. It has to be supported by people and process. So I'll end with this quote, which is from James Tagg, who's the co-founder of the Penrose Institute, Sir Roger Penrose that I talked about. And this is quite a poignant quote, I think. We're looking at how human brains work compared to computers, and I suppose the practical implication is getting humans and computers to work better together. And that's exactly what we're trying to do, and exactly the concept we should all be looking at, rather than let's let the computers do the job. Thanks very much for your attention. I hope that was a useful talk, and I'll be around for questions.